6. This is another way you can apply the sine trig function. It's on your postulate sheet there at the bottom. And we can use this when it's not a right triangle. Right now, all we've dealt with are right triangles. We can use this when it's not a right triangle. So the two cases when you can use law of sines. Now, you don't need to memorize this or write this down because you're going to end up finding out when you can use it. But it's when you have two angles and a side, or when you have two sides and one of the angles opposite one of those sides. This is when you can use this thing called law of sines. Okay, and we're going to go over what this looks like in just a second. But this isn't super important because you're going to find out sometimes you can only use the law of sines. Okay. One thing we do need to talk about, though, is how you label a triangle now. Okay. We're going to now label triangles. All the capital letters are going to be the angles, and all the lowercase letters are going to be the sides. Okay. All the capital letters are going to be the angles, and all the lowercase letters are going to be the sides. So you're going to see problems like here's capital A, capital B, and lowercase c. So that means I gave you two angles and a side. Okay. And the lowercase letters are always opposite the uppercase letters. So, for example, in this triangle, I have triangle ABC. Lowercase a is always the side opposite angle A. Lowercase b is always the side opposite angle B. And lowercase c is always the side opposite angle C. But now uppercase letters and lowercase letters matter. We use uppercase for angles, lowercase for sides. Okay. Because you're going to have to draw these pictures out yourself now. They're not going to draw them out for you. What the law of sines says is this kind of formula right here. This is on your postulate sheet. It says if you take the sine of one angle and divide it by its opposite side, it's equal to the sine of the other angle divided by its opposite side, which is also equal to the sine of the third angle divided by its opposite side. Okay, it doesn't make a lot of sense yet. Bear with me. We'll look at an example here. But this is what we call the law of sines, this formula. Okay, this is just another theorem where we can use sine. Sine's still, the ratio is still opposite over hypotenuse.
So is it always going to be sin?
Yeah, in this case we're always talking about sine. Right.
With just the laws of sine?
With just the law of sines, right. Okay. So let's look at an example here. Well, let's draw this figure out. It gives me lowercase s, capital R, and capital S, and wants me to find lowercase r. So let's draw out this triangle here. I'm just going to make some general triangle. It doesn't matter which order you label them, okay? But let's say I'm just going to go R, S, T. Remember, capital letters are the angles, lowercase letters are the sides, and lowercase t is opposite capital T. Lowercase r is opposite capital R. So, okay. Label that. Capital R is 53. Capital S is 61. I want to find lowercase r. Okay. So I just labeled everything it gives me. I'm looking for this piece. The law of sine says if you take the sine of one angle divided by its opposite side, which I have both of the s's, right? So if I take the sine of 61 and divide it by its opposite side, that should be equal to the sine of 53 divided by its opposite side, right? And then I could also do sine of capital T over little t, but I don't need that one because I know I'm missing both those pieces. Okay. So I just used what it gives me, and I just plugged it into that ratio or that proportion. And I'm trying to solve for lowercase r. So just like when you have two fractions equal to each other, what do? We have two fractions equal to each other when we have a variable. What do we do to solve for the variable? You cross products, right? Cross multiply, right? So we're going to cross multiply here. It doesn't matter which way you start with. Cross multiply here. You take r times the sine of 61. So I'm just going to write that out. R times the sine of 61 equals, and then I'm going to cross multiply the other direction. 2.8 times the sine of 53. Now, I wrote the 2.8 in front of the sine just because I don't want to accidentally punch into my calculator sine of 53 times 2.8. Because then that's going to give me the sine of 100 something. Right? So I cross multiplied. Got rid of the fractions. I'm still solving for r, so I'm trying to get r by itself. This is r times the sine of 61. So to undo that multiplication, I'm going to divide both sides by sine of 61. Right. Divide both sides by sine of 61. sine of 61 divided by sine 61. So those are going to cancel. So now I'm left with r equals this whole chunk of stuff. And this is just going to be something I punch into my calculator to get it to solve for me. So I want you to check on your calculator with me to make sure you get the right answer. So you get about 2.6. That's useful because this wasn't a right triangle, right? And I just used this law of sines theorem to find this missing side without knowing any. I just knew two of the angles and one of the sides. Okay, that's how you use law of sines. Questions with that? All right. On the next test, the last question say to solve a triangle. What it means to solve a triangle is that you find all the missing pieces. You find all the missing angles, and you find all the missing sides. So we're going to do two problems here. This is all we're going to end class today with. Two problems here where you have to solve the triangle. You have to find all the missing sides and all the missing pieces. Okay? Yep. It says triangle EFG. So I would always draw the figure just because it's easier to look at. It doesn't matter how you label it, but just use capital letters for the angles, lowercase letters for the sides. Okay. It gives me angle G is 70, angle E is 30, and side G is 8. So I'm going to replace this with 8. I need to solve this triangle. So that means I have to find side E, I have to find side F, and I have to find capital F. Okay, so I'm missing 3 pieces. One of those is really easy to find quickly. Which one is that? Capital F, why? Yeah, it's part of a triangle, right? 3 angles of a triangle add to 180. Always. Doesn't matter what type of triangle, right? So those two are 100 added together. So that means angle F is 80. All right, so that part's done. So now all I need to do is find E and F, lowercase e, lowercase f. Can I use Pythagorean theorem here? No, why? Well, one, I only have one side. What's the main reason I can't use it, though? It's not a right triangle, yeah. Pythagorean theorem you can only use on a right triangle. So I can't use Pythagorean theorem even if I had another side. So this is a law of sines problem. It doesn't matter which one I find next, E or lowercase f. They're both going to be the same difficulty. Okay. So first, I'm going to use the pair that I have. I have an angle on its opposite side. So I'm going to take the sine of 70 divided by 8. I always take the sine of an angle divided by its opposite side. Okay. So the sine of 70 divided by 8. Because the law of sines always says take the sine of the angle divided by its opposite side. So I chose these two to start with because I have both of them. And then whichever one I want to find next I can do. I can find E or F next. Let's say I'm going to find E. So then I'm going to take the sine of 30 divided by E. I could have found F next just as easily. I just chose E. So I'm going to solve this for E, so I have to cross multiply. E times the sine of 70. Cross multiply this direction. Equals 8 times the sine of 30. I'm trying to solve for E, so I'm trying to get E by itself. I'm multiplying by sine of 70, so to undo that, I'm going to divide by the sine of 70. That cancels. Divide by the sine of 70. So on my calculator, I want to take 8 times the sine of 30 and divide that by the sine of 70. So 8 times the sine of 30, that should be 4, divided by the sine of 70. You get about if you round up, 4.3. Anybody not get that when they punch it in? 4.256. Okay. So when you do 8 times the sine of 30, you think that comes out as 4, then you hit divided by sine of 70. So I now know this is about 4.3. So now I want to find lowercase f. And I can do that the exact same way. I'm going to go ahead and erase this work. Everybody got that? I'm going to find lowercase f the exact same way. And I'm going to still use sine of 70 over 8. I could use this, but my answer is going to be a little off because this is a rounded answer. So I'm going to go ahead and use still g. Sine of 70 over 8 equals sine of 80 over f. The sine of an angle over its opposite side. And then I'm going to cross multiply again. F times the sine of 70 equals 8 times the sine of 80. And then divide both sides by the sine of 70. Those cancel. So then on my calculator here, I'm going to plug in 8 times the sine of 80 divided by sine of 70. I think you get about 8.4. And one thing you can always kind of check your answer is that the largest side should be opposite the largest angle, right? 8.4 is the largest side, 80 is the largest angle. The next largest side is 8, which is opposite 70, the next largest angle. And the smallest side is opposite the smallest angle. Okay. And there I solved that triangle. I found the 3 missing pieces. All right, last one. In this case, the difference here, this will be the last one we do today. The difference here is I have 2 sides and only 1 angle, where the last one I was given 2 angles and 1 side. So let's go ahead and draw this one out. Again, it says solve the triangle, so I'm going to have to find all the missing pieces. Okay. It's triangle EFG. So that's lowercase e, lowercase f, lowercase g. And here it tells me capital G, the angle is 124. Lowercase e is 10. And lowercase g is 25. It says solve the triangle. I have to find both of these missing angles, and I have to find this missing side. I still can't use Pythagorean theorem because I know it's not a right triangle. We're given one pair already, right? We're given an angle on its opposite side, so we can use that with the law of sine. We could say the sine of 124, the sine of angle G divided by its opposite side is equal to, I can solve for either one of these, E or F next, because I have both their opposite sides. Let's say we're going to solve for E next. I just randomly picked E. We could do F. So that's going to be the sine of E divided by its opposite side. But this time I'm missing the angle, I'm not missing the side. That makes sense? Last time we were missing the side. So I used the law of sines here. I'm still going to cross multiply here, but this time I'm trying to solve for this angle. Well, let's go ahead and cross multiply first. Take 10 times the sine of 124 equals, cross multiply there, 25 times the sine of E. So all I did was cross multiply at that step. Again, I'm trying to solve for E. Let's first move this multiplication by 25 to the other side. How would I move a multiplication by 25 over? Just divide it, right? Divide by 25, that cancels. Divide by 25. So now I have 10 times the sine of 124, all divided by 25, equals the sine of E. Right, because I haven't broke away that sign yet. I can't just divide by sign. So now the question is here, how do you get rid of that sign so that you just have E left? How do you get rid of that sign so I just have E left? Well, just like before, yeah, your button on your calculator, if you look above your sign button, you have that sign to the -1. We call that sign inverse. That's the button that gets rid of that sign. So if you take sine inverse of that side, those cancel, and then you have to take sine inverse of all of that. So I'm going to do, this calculator can do it all at once, most of yours can. If not, just do the inside part first, and then take the sine of -1. So I'm going to do sine inverse of 10 times the sine of 124 divided by 25. And I think you get about, if you round up, 19.4. Now that I know that's capital E, so that's angle E is 19.4. Okay. I'm still trying to solve the rest of this triangle. I still have to find angle F and side lowercase f. Well, it's going to be really easy to find capital F, right? Because three angles of a triangle up to 180. So if I take 124 plus 19.4, that's 143.4, and subtract that from 180, I get that's about 36.6. Because I know three angles of a triangle have to add to equal 180. Now we have capital G, lowercase g. We were given both those. We have capital E, lowercase e. We have capital F. All we need now is lowercase f, right? So we're going to just use law of signs again. And again, I'm going to use the pieces it gave me because I didn't have to round those answers. If you wanted to, you could use those pieces. But I had to round 19.4, so I'm not going to use that to find another angle. So I'm going to again take sine of 124, sine of the angle, divided by its opposite side.
What are we trying to do now, F?
Lowercase f, right. So, because you always use the sine of the angle that's opposite it. So I'm going to do the sine of what to find lowercase f? 36.6, because that's the angle opposite.
Why are we using 124?
Because that's the piece it gave me. I have both the angle and its opposite side there. You could use this if you want, but since I had to round this answer, I'm going to use the one I already had. Divided by lowercase f. Again, that's the formula. It's on the bottom of your postulate sheet. So to solve this, I'm going to cross multiply. Take f times the sine of 124 equals 25 times the sine of 36.6. Again, I would write this 25 in front of that. That way you don't actually do sine of 36.6 times 25. And then finally to solve for f, divide by sine of 124, divide by sine of 124. Those cancel. F equals, so I take 25 sine of 36.6 divided by sine of 124. You get 17.97, so if you round up, be 18. Yeah, well, if it's 0.5 or above, you know what I'm saying. I didn't tell you what to round. Oh, it says round to the nearest tenth, so yeah, that's one decimal place. So it'd be 18.0. And there that triangle is solved.